Hello and welcome to Rudy's Retro Intel. On today's video we'll be looking at this VIC-20. It's currently showing black screen, and hopefully with some techniques I'll be showing you on this video we can get it running. So let's peek inside and poke around. Alright, this VIC-20 is showing signs of dead. So let's open it up and take a peek inside and do some diagnostics. Maybe we can find something visually that is causing the VIC-20 not to work. But before we start, I would like to do a test of the power supply. Now, the VIC-20, this is an older VIC-20, and this VIC-20 has a two-prong power connector. The power supply is a Commodore 117 volt in. Output is 10 volts AC, 30 amps. On the bottom here we can see it's indoor use only, shock, etc, etc. So this should be outputting 10 volts AC. Let's take a look. So we'll get our trusty meter out, turn it on to AC. Plug in one lead on one side, one on the other, and we're getting 10.7, which is good. Now, so that's good. Now, I just want to show you another power supply that comes with the VIC. This is also a two-prong plug, but this power supply, again for the VIC-20, shows an output of 11.5. Sure if we can see that here on the camera, but 11.5 volts. Why is there a difference between these two? I'm not sure. Why does this VIC have 11.5 and this has 10 volts output? I guess this might be the older and this might be a slightly newer one. I'm not sure. I'll have to look into that. So in the meantime, let's plug this one in into the VIC-20. I'm gonna power up my monitor, and let's tilt the camera a bit here. Turn it on, see what we get. Nothing. Black screen. All right. So it's time to open up. Unplug everything first, and let's flip this around. This one is a Commodore VIC. It is made in Canada. Let's see if you can see that. Made in Canada, 117 volts, 1 amp, serial number 249719. To open up the VIC-20s is just 3 screws on the front under the keyboard. And we pull that one out and one more. I like this case because it's just 3 screws. It's not like 20, 30 screws in some other computers. All right, let's open this up. And we can already see that the clips on this one have busted here and here. Quite common on the Commodore computers with these bread bin case. So let's take the keyboard away. All right, so this is definitely an older model. You could tell by the two-prong plug. It's got this large heatsink over the power voltage, the big shield over the port. And what do we have here? Let's take a look. Quick visual. Everything seems okay. Let's plug in the power. And we'll take some voltages. let's get this to DC voltage. I'm going to put one probe on the ground, and we're going to look at this voltage regulator right here. So we got ground on the rail here, and let's see what we see here. All right. So one of the first things I like to do when troubleshooting is look at the power voltages first. We'll do a visual inspection, check the power supply, make sure the power supply is good, check some voltages on the board, and then go to the 6502 processor, which is here, and just verify that it is actually working. I found that a lot of cases the CPU is faulty and causes black screens. However, many parts, the ROMs, other components, memory could also cause a black screen. But I like to start with the CPU gently. I find that's the best place to start. So let's take a look and go from there. Here we have a 6502 diagram. So we're seeing pin 1 is ground, pin 21 is 1 and 21 are ground. VCC is pin 8. So let's check pin 8. Pin 8. Let's see if I can get this meter into view. There we go. All right. So pin 1 is ground. So it starts from, in this case, the notch is facing this way. That means that pin 1 is on this side, and you count down to 20 and then 21 and all up to pin 40 is on the other side. So let's check out pin 1 first. 1 is showing 0 volts. And next was pin 8. So let's count 8. 8, I'm getting 5.09. Excellent. That means it's getting power. And let's check the other ground. Pin 21. Make sure that shows 0. Okay, great. So we are getting power to the CPU. The next step would be to check on our oscilloscope. So let me pull up my oscilloscope here and let's take some readings with that. So basically what I'm going to be doing here is checking out the CPU. What we want to do is, based on our diagram, is we want to make sure we're getting sync signal, IRQ signal. We have data and address lines. We want to make sure that they're showing some sign of life. So let's take a quick look at that. This is all I'm doing before I even plug in the Diagnostics cartridge. So let's have a quick look. Ground is there. And let's try, first let's look at sync, which is 7. So 7 sync, we are getting a signal. It looks nice, and let's look at some of the address lines. So let's make our way down. I'm just randomly picking address lines at this point. I'm not looking for any particular address line. Getting a signal there, getting a signal there. Looking at some signals there. The last few are address lines on the other side of the chip. All right, now let's look at the data lines. So that's pin 26 to 33. And we can see we are also getting some data on the data lines. Not that great though. Let's see if we can pick one and do a lock. Let's see what we're getting. Next, I want to look for the out signal. I think it's producing a signal out, so we can see on our diagram, pin 39 is an output, and pin 3. Let's take a look what that means. So pin 3 is a clock. Let's look at pin 3 now. Pin 3 is producing a clock, but it is the signal is jagged. It's not a nice square wave. It should be a nice ramp, straight up, cross, and then down. Let's look at, the other one, 39. 39, so that's the second one from the top. Again, so we're getting some kind of rounded signal. This should be a square wave, something like that. We can see some square waves here. Again, not the best square waves, but we are getting a form of a square wave. All right, so what else should we be looking at? Pin 40. I'm not getting anything on pin 40, which is fine. Let's take a look here. What else have we got? So the address lines, pins 36 and 35 are not used. Let's look at the IRQ, which is pin 4. I'm not getting any signal there at the moment. And MI. So IRQ, the interrupt request, going low, the CPU loads the computer with the values after processing a current command. So looks like it's not processing any command at this time because we're not getting anything on this pin right now. WMI, non-mask interrupt, goes low. The CPU loads the PC value stored after processing the current command. So let's relook at pin 6. 1, 2, 3, 4, 5, 6. As you can see here, we are not getting any signal. If I zoom in this, it's just noise. This tells me that the good starting point would be to look at the processor. Next would be the video chip, kernel, the ROMs, and the memory. But let's start off with the CPU. Okay, get my trusty IC puller. And let's see if we can get a better view of this on the camera here. Let's take a look here. All right. Make sure the power's off when you put the chips. And we will do that one there. And I have a known good MOS 65028 chip. The A is for no idea. Anyways, let's plug. Oh, this one's in backward. Again, the notch. Be very careful. Plug it in the proper way. If not, you're going to start frying all kinds of stuff. And not just French fries. Okay, that's in. Let's power it up. Oh, and voila. We now have a very nice video of the screen. I'll have to pardon this setup. I don't have a proper setup here for doing video capture at this time. I am looking to get something. In the meantime, I'm using what I have. All right, so quick fix. Wasn't bad at all. Again, to review, I would check the power first, make sure it's producing the proper voltage as marked on the power supply. Check voltages on the computer. Now, when you're probing your voltages on the computer, leave them for a moment because it might show 5 volts or 4.8 volts or 4.9, something like that. And then all of a sudden it starts to drop. If the value of the power supply is dropping from 5 volts or thereabouts down, it could be a very serious issue on the computer. It generally means that there's a short somewhere. So be careful not to leave it on for a long time if it's doing that, because it will definitely fry something else on the computer. Now that we have this thing up and running, let's put in some diagnostics cartridges and take a look. I have two different diagnostic cartridges. I have this one here. It's the VIC-20 Super Expander 2 with a diagnostics chip inside. Has a reset button. Just a couple of chips. Very nicely slim built. I also have the feature was 8-bit the penultimate plus cartridge. This cartridge is excellent in the sense that it has a built-in diagnostics and it has games built in. I believe it's 70 games. It also has memory expansion. It's a really, really great all-in-one cartridge for the VIC-20. Let's plug this one in and take a look. Actually, before I do that, let's plug the other cartridge in. Let's plug in the dead test cartridge. Now these slots, you have to be careful you put them in because this does not have a case. Make sure we're powered off. Although I've heard people able to plug in cartridges and so on with the power running, I don't recommend doing that. One small mistake and you have an issue. I like to keep all my special chips and boards into a Ziploc bag just for safekeeping, keep them clear and dry. This is a, oops, this is obviously still on. This switch is not the greatest. It looks like this switch will need to be replaced. It's very difficult to turn on and off, and at times it's very simple. Just a quick touch turns it on. Now, this adapter is for the keyboard. It also has an LED light on there. And I did notice that the pin, this pin here is not quite straight. Let's fix that up a bit. There we go. And plug the cartridge. Not the cartridge, let's plug the adapter in here. Busy working and talking at the same time. I guess I'm not very good at multitasking here. Let's plug that in. Let's turn off the scope. This is a test for the different ports. If you don't have a cartridge of some kind like this, you're not 100% sure that the computer is working properly. So we plug this one into the serial port, one to the user port, and one to the serial port. And yeah, we will take a quick view on our screen and see what comes up. And there we go. We have the VIC-20 Diagnostics. All right, let's turn it on and see what we get. And we get the VIC-20 Diagnostics, checking page 0, okay, stack page is okay, RAM test 01 is good. Let's see if 02. The clock is running here, you can see it's moving. Looks like so far so good. And doing a pattern test. Color RAM's okay. Color RAM test is good. ROM check FF and 4E bad. Saying that this ROM is bad, although I think this Diagnostics cartridge has an issue with detecting the ROM. I believe it could be some defective piece of the software on the Diagnostics cartridge. In the meantime, let's unplug this one. And plug in our penultimate cartridge. The penultimate cartridge is not compatible with a Diagnostics harness, so we'll have to remove that. I have to see what harnesses do work with the penultimate cartridge. Let's first kick in the cartridge and make sure we're getting a nice screen. Yes, it is great. It looks fantastic. However, on the cartridge itself, there is a button you can press. If you press and hold this button on boot up for approximately 10 seconds, then let go, it should boot up right into the Diagnostics mode of the cartridge. So let's give that a try. Power it off, make sure it's off, pushing down and turning on, waiting approximately 10 seconds. And then I will let go. And here we go. Now the Diagnostics dead test cartridge software kicks in. Let's let it run through its paces. So RAM 0 is good. Let's look at 4, 5, 6, and 7. I just turned the volume up on my monitor. It does produce noise for some reason, but the videos, at least it's showing video, and it will play sound through it fine. It just, when it's not playing any sound, you get a small hum. I will have to look at that in probably future videos. But right now, we don't care. We are looking at RAM testing. So far, RAM 0, 4, 5, 6, or 4 and 5 have passed. 6 is testing right now. While we're waiting for the test to finish, I find that the Diagnostics cartridge for the Commodore 64 is much better tool for investigating and troubleshooting issues. The VIC-20 is kind of limited to what's really out there. I haven't found a good Diagnostics cartridge. I've used these two. It gets me to where I need to go for now, but if I want to do a more depth in analysis, I would have to get a proper Diagnostics cartridge. And a few of the reviews I've read, some are great, some are not great. Nothing really good that I found. If you know of any, please leave comments in this video. I'd love to know what you think about a VIC-20 Diagnostics cartridge. And if I get some good consensus, I'll pick one up. So color passed, the character ROM standard, and the basic is good, and TSC. So far, I believe it's passed. It's going to run through the test again. So that concludes the video for now. We're going to basically bolt it back up again and go from there. Thank you so much for watching. Have a great day.